Welcome to the Smart Driving Cars podcast. Thanks for taking the time with us. This edition is sponsored by the Smart ETF's Smart Transportation and Technology ETF, symbol MOTO. For more information, head to motoetf.com. Technical support is provided by CARTS, the Corporation for Automated Road Transportation Safety, a 501c3 nonprofit dedicated to safe and high-quality mobility for all. I'm Fred Fishkin, along with the Faculty Chair of Autonomous Vehicle Engineering at Princeton University, Alain Kornhauser. Hi, Alain.
Hey, good afternoon, Fred.
We have a great and important guest for our audience from Qualcomm, but first, this message. For years now, companies big and small have been investing billions in building vehicles capable of driving themselves. The advancements have been great. The testing has been impressive. And now it's time to take the technology and all that has been learned and put it to use in places where it can do the most good. Providing mobility, life-changing mobility, for those who have had limited options at best. Trenton Moves will provide safe, equitable, affordable, and sustainable high-quality mobility through the deployment of 100 autonomous vehicles throughout the state capital. It will be the first large-scale urban transit system in America to be based entirely on self-driving shuttles. A first in using the technology where it can do the most good. 70% of Trenton's households have limited access to a single car or no access at all. The state, the city, and the community, teachers, students, young and old, are all part of the Trenton Moves effort and planning, and it will be a model to build on for many others in New Jersey and beyond. Join us at the 5th Annual Princeton Smart Driving Car Summit, June 2nd, 3rd, and 4th, to learn more and be a part of the next step in providing mobility for all. Visit cartsmobility.com for more information and register today. We'll have more on the summit a bit later on. Right now, joining us from Qualcomm is Senior Director for Product Management and ADAS and Automated Driving Lead, Anshuman Saxena. Hi, Anshuman.
Hey, Fred. Good afternoon.
Good afternoon, Anshuman. Really nice to have you here.
Good afternoon, Alain.
Well, to begin with, let's get an overview of the work going on by you and your team at Qualcomm. Tell us more about the focus.
Yeah. So, okay. So I'm working with Qualcomm for over 7 years now, and when I came in, we were starting our automotive journey in the cockpit space, and since then we have been focusing on how do we get work in the ADAS space started. So for last 7 to 8 years, I would say almost a decade, we have been focusing a lot on how do we bring the technology solutions that Qualcomm has into the ADAS space. For example, right? I mean, we have been doing a lot of work in the artificial intelligence space, a lot of work that has gone into the localization space, the robotics, and the drones, etc. We consolidated the team into what we call as a Qualcomm ADAS and autonomous driving research team, and started this program back in 2015 timeframe, where we brought in the sensors into the car, understanding the system, exactly how and what it needs to drive a car, and then build on top of it that, what will we need from a hardware compute platform, from things where we excel, like the SoCs and the technology areas. And then over last 2 to 3 years, we have been consolidating a lot of assets inside the company or acquisitions from outside, where we got in the acquisition of Arriver. Arriver was a software house from Veoneer, which was focused primarily on the camera perception for the forward cameras and then the drive policy systems. We acquired that and closed the transaction, and now Arriver is part of Qualcomm. And during this phase, we have been working with many customers to understand, to learn the system requirements, and have been building a continuously step-by-step portfolio of hardware SoC solutions, platform software, middleware to the CV stack, and now the driving policy solutions.
And the purchase of Arriver gives you some new driver assistance technology?
Yeah, again, Arriver actually comes as a software group that has been with the old Autoliv, which was converted into Veoneer, and then had been working with the likes of Zenuity as part of the driving policy solution. So Arriver has a vast experience of over 15 to 16 years in this space, where they have been delivering the safety solution, the active safety solutions into the auto industry. Now, they are now in the 5th generation of what we call as Arriver Vision Perception Solution. And what it means is that there is a big know-how of what it takes to make a product. That is really the difference between showing a demonstration versus putting a car on the road where you can trust what the car is seeing and can go into the decision-making process. That is the value that Arriver brings from a learning and know-how of the production and the commercialization techniques of ADAS systems. Alongside that, Arriver also brings a significant value in the driving policy solution. So, for example, there have been public announcements of Arriver solutions going into multiple vehicles, like the Volvos and the Polestar brand of vehicles. The recent announcements on the Mercedes-Benz L3 systems, which are on the road in Germany, are also driven out of the Arriver perception. So yes, there is a significant know-how, production experience that they have had on the camera perception, on the driving policy, which now ties it all together to Qualcomm's Snapdragon Ride platform, so that you can get the best of all worlds. You can get the best of the underlying IP and the technology solutions that we pack into a single SoC, a single hardware platform, the integration of the whole system, tied with the leading computer vision stack, which will be a big alternative to the black box solutions that exist today in the market, and a full drive system which can scale from an NCAP requirement, a level 1, level 0, level 1 requirement, all the way to a level 3 requirement with automated driving on the road. So that's what Arriver brings to Qualcomm as part of the Snapdragon Ride solution.
I guess I wasn't aware that that Qualcomm was really pushing into this field. I just recently became aware of all your efforts, and I really think that it's really fantastic that you're in there, given Qualcomm's history and its influence in mobility, and going back to. I go back to all the way the beginning, the OmniTracks with you guys. Absolutely. And so on. I mean, it's kind of amazing, and it's really wonderful to see you in here. I have, we sort of here take a couple of positions on automated driving here. We sort of have the ADAS portion. In other words, the kind of things that really improve the comfort and convenience and safety of vehicles that we all buy, or many of us buy in showrooms. And then on the other end is the driverless business, the things in which we're going to be chauffeured by Qualcomm chipset that goes out and does it for us. And to me, I've always taken these things as really two different things. One could evolve into the other, but they're really fundamentally different businesses, at least in terms of the way we've looked at it. And if we could maybe spend a couple minutes talking about maybe your philosophy, or maybe you can correct me in terms of my view on a couple of things with respect to ADAS. And as I look at the car that I happen to have that does a lot of nice things for me. One of the things that sort of has bothered me with the way that has evolved is that there's the separation between what's done for me to be able to give me comfort and convenience in driving versus what's being done for me on safety end. I think in my car, I have an automated collision avoidance system. Luckily, I've never executed it. Luckily, because my understanding from I think I did read the manual once, maybe, or maybe I was told. I doubt that I read the manual. But that you know, at some point, 1.6 seconds before collision, because it sits there and monitors time to collision, I think, or at least that's what I'm told it does. At 1.6 seconds, then, you know, like windows close, roofs close, bolsters come down to keep the engine from taking out my legs. The seatbelt tightens, and the damn thing just slams on the brakes, and you know, to try to keep me from hitting something. Okay, that's on the one hand. On the other hand, I have this nice, great, intelligent cruise control system that, you know, I use all the time. Actually, I really do use it all the time, and it's fantastic. I don't think it's ever failed on me. Okay, it keeps me going at a constant speed, and you know, if I start crawling up somebody, it just behaves so darn well.
Yeah.
But it seems that those two systems are separate. Okay, as opposed to being combined. Why aren't they combined? Why is it that I ever turn off my intelligent cruise control system? Really? Why should it be turned off? I mean, even if I hit the brake, it turns it off, which drives me nuts. That should turn off the acceleration function, not turn the whole thing off and said, hey, Alan, you're on your own until you get 1.6 seconds to collision, and then we'll take over again. Yeah. Doesn't put me in that what I'd like to call no man's land in there. Okay. Right. Do I have it wrong as the way these things work, or how do you see these two systems? One is the one that, you know, is just like fantastic, and the other, I hope is fantastic, but I've you know, luckily, you know, I haven't been there yet. Talk to me here, or do I have it wrong?
No. I think there are your comment and the question behind that is pretty loaded. So I'll try to kind of break it down into some pieces and put some thoughts on that.
If we can discuss a little bit. Thank you.
So I think there are multiple things that go in here. I mean, the emergency braking system or the collision avoidance system that you talked about, right? It is driven as a safety critical requirement, right? And like we have belts, like we have airbags, like we have every other safety feature. This has been improving. I mean, I've seen this, and I'm sure you have seen this industry grow like that. That, you know, it was more of a warning system in the past. That, you know, pay attention and take control of the brake, versus now it has become a standard emergency feature and emergency braking feature. And as you would notice that, you know, there are regulatory bodies like the new car assessment program, the NCAP from Europe or China, or in Asia, NHTSA in US. There are multiple regulations that are behind it, and that's like the minimum mandatory thing that is becoming critical on pretty much every vehicle right now. And you know how they do it, right? I mean, it will be either a radar or a front camera or a combination of both to do a minimal system, because it's a cost driven thing as well. Whenever there is a mandatory feature, it's a cost that adds to the car. It has to be done, so they try to find out what is the right mix of cost and safety, and they put it there, right? I mean, safety cannot be compromised. Now, you took the example of the intelligent adaptive cruise control, right? When you put the car in the adaptive cruise control mode, and you are going to be following a car in front of you, speed up or slow down based on the car in front of you, unlike the traditional cruise control where we just put it with a button, and the car will drive at that speed, but you have to take control of the brake. Now the braking is also come into the automated control system. Now, you can keep expanding that, right? You can keep expanding that by saying, you know, now I have to do a lane change mode as well. Like, you know, if you are driving and the car is slow, why should I be on the same lane? Why can't I take a left lane and pass it and then come back to my lane and all? So you can keep expanding. These things are called the operating design domains, or the ODDs, and you can keep expanding. What it means is you need to have a better view of the surroundings. the environment model as we call it. For that, you need a better sensor belt. You need to sense around the car. You need to have a better prediction of what the car in front of you might be doing. So you need, overall, what I'm trying to say is you need more sensing, more understanding of the environment, more compute, which comes at a cost. So again, the point becomes, can every vehicle afford it? Maybe, maybe not. Not every vehicle is designed to have the cost on it. And hence, typically the traditional systems have been that, safety critical systems, mandatory on every car, has to be there. And then the adaptive cruise control systems, which by the way, are not completely independent. They take the input. So whenever your adaptive cruise control system by mistake goes wrong, right? Or the car in front of you just slams the brake immediately, your emergency braking system is going to take over and say, I'm going to slam the brake as well because I have only a one second to collision and take control. But this is state of today. What we are seeing in 2025 timeframes, one, the safety requirements driven by Euro NCAP or any NCAP for that matter is expanding. And the systems are becoming more kind of available where you have a lot more sensors in the car. So emergency braking is becoming a critical component of the bigger system, which is going to be driving your adaptive cruise control. So emergency braking is part of it. Now, one very important thing, and this is where the production system versus a demonstration system makes a big difference, right? You cannot compromise on the minimum requirements of the emergency braking system that have been set up by the regulatory bodies. And that's where, again, somebody like Arriver, who has been doing this, has to come in and provide a solution which may or may not be adaptive cruise control solution. It's all going to be in one system. It's all going to be well interconnected so that it seems one system for you. But there has to be a production know-how that has to go in to develop those systems. I don't know if I kind of gave...
Yeah, I agree with you, and I see it, and that's a real advantage that you have. It seems to me that just from the outside looking in, and I am very much on the outside looking in. I mean, I'm here in some university bubble here in Princeton. I can't, I can't see very well out of it. But to me, I think what I see is maybe a real opportunity for Qualcomm, because what you've done is to integrate these things. I agree with you. Absolutely, the safety is absolutely required. Yes. And it's great that we're now at a point where they're not just warning us. If the system thinks the brakes should go on, it puts the brakes on. Darn it, come on, exactly. Cut it out. I mean, look, let's do that. Thank you. And they're all becoming good enough. Whether or not the swerving and lane changing, I just think that's, I'm happy to stay in my own lane and not die, I guess, as far as I'm concerned. No, but to me, working backwards on that, as I get from, it being infinity to time to collision, to a 1.6 seconds time to collision is, in a sense, a continuum. You get there continuously. Yes, depending on what's happening in front of us and what we're doing, it's continuous. And it just seems to me that the two things should integrate themselves. And in fact, the opportunity in the design of how the intelligent cruise control system works, that in fact, as long as you're 4, 5, 6 seconds to collision, don't slow down very fast. But it seems like there's an opportunity to really shape this thing to a much better customer reaction. Absolutely. As a driver, opportunity if you integrate these things and to do it in a way so that, the thing that has bugged me that nobody could give me an answer to, maybe you can, that nobody's ever been able to, is why if I tap my brakes on my intelligent cruise system, control system, it turns it off. And it's always driven me nuts. And I suspect it is some SAE requirement that when it was dumb cruise control, okay, and you tapped your brakes, you said, oh my goodness, I want to stop the acceleration function, okay, which is what I had in dumb cruise control, but that was the only function I had. So might as well turn off the acceleration function, turn the whole thing off. There's only one thing to turn off, turn it off, okay? now that we're controlling two things, the brake, as you point out,
Right.
and the accelerator.
Right.
Okay, me touching my brake, I don't know. Am I the only guy in the world that says, "Hey, I just don't want to go as fast. But I want to slow down. So turn off my acceleration function, but leave my braking function." If the intelligence that you're getting on your chipset with all your computation says, "Hey, Alan, you're going too fast," you should. Why does the braking function get turned off? And it's nobody's ever been able to give me a straight answer to that one. And maybe, I don't know, maybe I haven't been listening. I don't listen very well. Fred will tell you. So maybe it's my problem. Go ahead.
I can tell you that if Anshuman can solve this for you, he'll love you forever.
Oh no, I mean, this is driving me nuts. This is simple to me. I mean, this isn't, this is in Control Vehicle 101 or something like that. I don't know. Go ahead. Go.
Yeah, no, I'm sure, Alan, you have talked to many, so I'll just attempt with my side of the response. Not sure.
We're just chatting here.
Yeah. So one thing that is there, right? I mean, typically in the safety systems, and this is why you see now big driver monitoring or the attentiveness of the driver is becoming important. I think it's probably driven because of the safety things. For example, you are in an intelligent adaptive cruise control. You are in the lane, following the car, speeding up. You have set up a speed limit that, I'm going to be at 70. Of course, you can make it even more intelligent based on the maps that, limit is 55. Alan cannot drive 70.
Fantastic. Yeah.
Right. Yeah. So, but suddenly, and the car is adapting itself based on the car in front of you. But suddenly, for example, Alan pushes the brake, right?
Yeah.
Which for the car means that something that the car has been doing was not up to the mark, and Alan had to intervene, right?
Sure.
Okay. Fair enough. Yeah, there was some reason, and you try to brake it, because slowing and speeding up it can do by itself. Yeah. So now what it's trying to do is getting you in the loop again. That Alan.
Yeah.
There was a reason probably because of which you press the brakes.
Yeah.
Are you feeling comfortable that you would put it back in the adaptive cruise control mode or not? Right? So you are now suddenly part of the system which says, okay, maybe there was something, I saw something which made me push the brakes, but the road looks clean. I'm all okay. And I am taking the opportunity to put the car back into the adaptive cruise control. Once is the car doing it by itself. And that's where it becomes the level 2 versus a level 3 kind of discussion and all that stuff, right?
Am I the only guy that feels? I mean, it drives me nuts. I can't be. It just surprises me that, or do I have the behavior wrong?
No, absolutely. Your feedback is very valid, and there are systems which you would start seeing them for sure in the upcoming years, where, I mean, it's multiple factors, right? It's a factor of sensors, it's a factor of the compute, and a factor of how the driver behavior is. But going forward, you will start seeing a lot more of this automated controls for the safety functions, like you're saying, right? I mean, even if nothing is on, you would like to have the braking exactly in the same way instead of a jerk 1.6 seconds reaction.
I think so. I mean, maybe I'm the only consumer out there, and I know that with respect to an OEM and so on, we've gone through 100 years of selling cars to people in which the driver is the king. I mean, they are the know-it-all. They are the owner. They know better than what And it's been a real. I mean, it's taken monumental efforts to go in there and say, hey, no. Look, we now have we have analog brakes that say you don't really know how to push the brakes, and I'll take over. And we have a stability control system that says, hey, Alan, you're going around this corner way too fast. We're taking over. Otherwise, you're going to lose your rear end. So,
exactly.
I mean, you've made some advances in here. And of course, the automated emergency braking system is another one.
Yes.
Okay. I'm just trying to encourage please continue. Yeah, I think I know what I'm doing, but I really don't. And in fact, hey, maybe sometime I'm going to say, well, look, you shouldn't have done that. You shouldn't have tapped at the brakes. Take a look at how your code is structured.
No, absolutely, it's a good input.
You know, maybe you already, and maybe I just haven't caught up.
So there are multiple things that are happening in the industry to exactly solve the problem you're talking about. Foremost, focusing on safety. How do you make sure that the person behind the wheel, everybody inside the car is safe in a very, very kind of comfortable way, so that you don't feel the jerk. But at the end of the day, you cannot end up in an accident is really the target, the goal of everything that is being done in the ADAS space, right?
Right. And that, to me, that's the real wonderful thing about all this code and all this sensors and so on, is that we've gone from crash mitigation to crash avoidance. Exactly. It is, I mean, it is, great. We have airbags, we have all this other stuff and crush zones and so on that keep us from dying on the crash and do the mitigation. Now we have the opportunity and really need to focus on crash avoidance, so that there is no crash. And then, I mean, that's the real benefit of this technology. And if it sort of every once in a while makes it seem as if maybe the car is not quite reacting the way we would have liked, the fact that we're able to continue on and say that afterwards without having to go through a crash is to me value in a fundamental value.
Right. And I think that is really the way we at Qualcomm are looking at this, primarily, right? I mean, because how do we improve the safety features? And I'll just take one minute or so for showing one example. For example, right? I mean, the better judgment is when you can kind of see 500 meters out, right? What it means is that you have to increase the resolution of the cameras. You have to have multi-cameras, more radar sensors, which basically means a better processing, more AI capabilities, more data, annotation, everything. And then you would still probably come across where you have curves and turns around the roads, where you cannot, even if you had a great camera, it's a line of sight sensor, you cannot really see. So there the technology of communication comes in. So at Qualcomm, what we are doing is all the developments, all the technology solutions that we have been working on, whether it is to do with AI, whether it is to do with high performance compute, whether it is to do with 5G connectivity or cellular V2X, or even the services like the maps, etc., that we can kind of associate it to. All this is coming together in solving the problem in a much more systematic way versus doing one problem at a time kind of a thing, which is pretty much what you were asking, that emergency braking to intelligent cruise control should all be tied together into one system, solving it in a holistic fashion. And that's exactly what we are doing at Qualcomm.
Yeah, which is really great.
Does your expertise, long-time expertise in the communications field, like the phone Alan held up a few minutes ago, does that give you a leg up over competitors in this space in any way?
It does. And if you have been following us a little bit, we talk a lot about what we call as a Qualcomm One technology roadmap, right? And it is not just communication; it is everything that goes into building a phone. Phone is a very, very, very complex system. Now, complex system because of the constraints on the power consumption, constraints on packing up a lot more compute into a very, very small form factor. But the car problem is different. Car problem is to try to solve this complex sensing, complex environment modeling, and complex communication requirements anytime, everywhere, in a very, very safe fashion. So what we at Qualcomm have been doing is that, every block, take for example, artificial intelligence processing. We invest in the technology differentiation, in the technology development for artificial intelligence. But with automotive being a primary driving factor, because the requirements of AI on an automotive or a data center is very different from what is there in the mobile. The technology roadmap is driven from the different application domains, but it's one implementation that is benefiting mobile business, IoT business, automotive business or a data center business. Same with communications, for example. Our know-how in the communication space from 4G to 5G has helped us to develop this technology called cellular V2X, right? And it has been heavily deployed in many regions in the world, and is also kind of getting accepted in many other regions, right? In China, it is getting a significant deployment. And the idea is that you are able to bring the communication technology to do a vehicle-to-vehicle or vehicle-to-infrastructure communication and get me a non-line of sight sensing into the car. So yes, at Qualcomm, we see all these areas where we have our leadership in best power performance, thermal solutions, best computing solutions, the assets that we have developed over years on the mobile space for tools and SDKs are all part of our development philosophy for automotive.
We'll be back, but this is a good time to remind you about our sponsor, the Smart ETF's Smart Transportation and Technology ETF, symbol MOTO. To get more info, head to motoetf.com. On the website, look for a white paper called The Smart Transportation Revolution. It's under the Insights and News tab. Lots of great information there that can help you make informed decisions about investing. ETFs, you may know, can be a good way to spread risk with investments. Maybe focus on a particular category of stocks. That website again is motoetf.com. We're back with more of Smart Driving Cars and our guest, Anshuman Saxena from Qualcomm. Anshuman, in the overall picture at Qualcomm, I know this may not be your place to say, and you might be biased. How big is the automotive business opportunity here?
Interesting question, right? So again, I think it is very important for Qualcomm, and it's coming from the overall Qualcomm leadership that, diversification is key for Qualcomm's growth in the future. We have a very strong mobile business, and it continues to be our strength. But at the same time, we have been diversifying into multiple other businesses, including IoT, automotive, etc. And as of the last financial results that we had quoted, the $16 billion pipeline for automotive. So that kind of tells that, automotive is a very critical part of Qualcomm's overall diversification strategy and the future-looking growth vectors in the coming as part of this decade and the upcoming years.
Well, you guys are all about mobile. There are two ways that we're mobile. We walk and we drive a car. I mean, when you look at it, you look at the way we get around, that's the way it is.
Yeah.
And I think, you are fundamental to it. Whether we're going to get to V2V and so on, some things that we were talking about before, who knows? I mean, that is an enormously challenging problem. There are some things that you do have when you're mobile. Some of what's been low-hanging fruit forever. You basically have each car that's going down the road knowing what the coefficient of friction is on the road at every location and every lane.
Yeah.
Okay. I mean, just maintaining that so that you find a way to deliver that to my vehicle up ahead in somewhat real time. Just do that. I mean, that the whole stability control business changes. Certainly in inclement conditions when one is dealing with inclement weather, and not that we should all be going so much faster than what we're going. Maybe all these systems go in and keep us from going that fast and keep us from getting into trouble. I mean, we're our own worst enemies when we drive. We're the ones that sort of get a little bit ahead of ourselves, and we need a lot of help from you and from the technology, and to sort of, hey, cool it a little bit. My goodness, you'll get there, and you'll get there. Otherwise, you won't. So I mean, so I mean, to me, that there's just such an enormous opportunity for Qualcomm in this space, and I'm glad to find that you're really out there, doing it and doing it heartily. So congratulations.
Thank you, Alan. Thank you very much.
A couple of other headlines that we want to get to. The University of California, Irvine is out with a research report saying autonomous vehicles can be tricked into dangerous driving behavior. they're talking about bike or traffic cones or a box in the lane can cause driverless vehicles to come to a dangerous stop in the middle of the road. And Alan, you took a look at this and thought to yourself,
I don't know. I mean, don't researchers have better things to do? My goodness. I mean, what are they trying to put magicians out of business? Magicians have been fooling me, for how long? I mean, sure, you can go out there and do this stuff. Come on, that's this is clickbait. You have to have better things to do than that. This is serious business. Okay, I mean, if we want to go, mess around with a traffic system, I can send my dog out there in front of a car and jack it up and steal its wheels. I mean, whatever.
From Wired, a look at an incident in San Francisco where a fire department truck responding to a fire was blocked by a Cruise autonomous vehicle when it tried to pass a garbage truck by moving into an opposing lane. The Cruise vehicle, without anyone inside coming the other way, of course, did not move out of the way. And some people are wondering, a human would have gotten out of the way. So
well, I'm so glad that people in San Francisco, again, this is the news that they want to put on there. Given the other news that's been in the news, it's nice to hear about that too, because the other news is really ugly. So yes, good, but come on. I mean, whatever.
The Smart Driving Car Summit coming up. Look at this week, Alan.
Oh my goodness, what
It's
do we
looking
got
pretty
to do, Fred?
great. What's the update on the agenda here? It
I don't
gets
know.
better every day.
Looks like it's going to happen. I know. Sorry, folks. We had said it was. I sound like Elon, I guess. Oh, we were going to have it in November. We didn't have it in November. Then we were going to have it in May. We didn't have it in May. We are going to have it in June, though. It is coming this week. I mean, either it does or it doesn't. Things look really great. I think that as we've done with the other summits, this is all about us discussing what to do. It's not about, we are still at the very beginning of all this, absolutely the very beginning of what we've yet to generate any societal value out of the driverless stuff. At least we're generating some societal value out of the ADAS. But on the driverless side, we haven't even started and how much has been invested. So here we're going to discuss how we do it for real, do it for not testing, but actual deployment, deliver value to individuals and improve their quality of life from it, and deliver some real societal value out of this technology.
Exciting stuff. And there's more information about it at cartsmobility.com. You can look at the full agenda, and if you can make it, we'd love you to see you there. You can register.
Yeah, come on. We're just going to get in there and discuss. I guess we have essentially as good of people from around the world coming, certainly that I know, and they all want to be here at Princeton, and we're going to see how we take it forward.
Terrific. Anshuman, we want to thank you for spending time with us today. Really valuable information, and congratulations on all the innovation that you and your team are achieving.
Thank you. Thank you very much, and have a great show.
Yeah, and thank you for coming on. Thank you for discussing with us. Again, this is what we like to do. We like to discuss. I mean, it'd be nice to. I wish I knew what to do. I don't. And it's these are all great technologies for very good things to improve our quality of life, and let's do it.
Absolutely.
Thank you to our sponsor, the Smart ETF's Smart Transportation and Technology ETF. The ticker symbol for the ETF is MOTO, and more info is available at motoetf.com. Technical support is provided by CARTS, the Corporation for Automated Road Transportation Safety, a 501c3 nonprofit dedicated to safe and high-quality mobility for all. You can find us at smartdrivingcar.com, also on Anchor FM, Spotify, TuneIn, Apple, Google, Spreaker, wherever you turn to for podcasts. Your smart speakers can play us too. You can find my tech reports at techstination.com. I'm Fred Fishkin along with Alain Kornhauser. Thank you for listening or watching. Please stay safe.
And thank you very much.
Thank you.